Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n minus 6 to the power of 4 plus n minus 8 to the power of 4 is equals to 16, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first I can rewrite this nice equation as, here we have n minus 6, and we will write this n minus 6 as n minus 7 plus 1 and its whole power 4, plus similarly here we can write this n minus 8 as n minus 7 minus 1 and its whole power 4 is equals to 16. And now you can see that we will make here the similar term, which is n minus 7 on both of these terms, so that now we will just put here this n minus 7 is equals to y. So when we take y is equals to n minus 7, this expression will becomes in the form of y plus 1 to the power of 4 plus y minus 8 to the power of 4. Sorry, here we have minus 8 and we can write it as minus 7 minus 1. Okay, this is the minus 1, so it will becomes y minus 1 whole to the power of 4 is equals to 16. After this step we will again rewrite this equation, and we can apply here the nice square identity. And you know about this identity, if we have a plus b and its whole square, it is equals to a squared plus 2 times of ab plus b squared. And now we can apply here this nice identity on both of the terms. So first I can write these two terms in this form, so that here I can write this y plus 1 to the whole power 4 as y plus 1 whole squared and its whole squared, because you know that if you have exponent to the exponent, so these exponents are multiplied by each other and you get y plus 1 to the power of 4. Similarly, you can write this term similar in this way and you get y minus 1 whole to the power of 2 and its whole squared is equals to 16. And now you can see that we will make here this formula on both of the terms. So now we can first open the inside term of the whole square, so that we will get, or we can first open this square and you can get simply here y squared plus 2y plus 1 and its whole squared, plus similarly here you can get y squared minus 2y plus 1 and its whole squared is equals to 16. After this step we can again use here another nice uh, square identity. And you know that if we have the square of the sum of three terms, which is a plus b plus c whole square, it is equals to a squared plus b squared plus c squared plus 2 times of ab plus 2 times of bc plus 2 times of ca. Okay, now we can apply here this nice identity on both of these two terms, so that after applying this identity in the first term you can get the output in the form of, here you have first square a squared, so here you have the value of a is y squared, so it will becomes y to the power of 4, because y square will becomes y to the power of 4, plus here you have 2y whole square, it is equals to 4y square, and plus 1 square is equals to 1, and plus 2 times of ab, and the value of a is y square and the value of b is 2y, so 2 times of this will equals to 4 times of y cubed, plus 2 times of bc, and b is 2y, c is 1, it will becomes 4 times of y, and 2 times of ca is equals to simply 2y square, and plus now we can open similarly this formula, and here you get y squared. So you know that y squared is equals to y to the power of 4 plus 4y squared plus 1 and minus 4y cubed minus 4y and plus 2y squared is equals to 16. So now I can apply this formula on both of the terms, and you get the output in this form. And now we will just make the little bit simplification here, and you see that here we have plus 4y cubed, this is minus 4y cubed, these are gone, and this is plus 4y minus 4y, these are also gone. And now we can add y squared plus y squared, it will becomes 2 times of y to the power of 4. And similarly here we have 4y squared plus 2y squared is equal to 6y squared and plus 4y squared, 4 plus 2 6, 6 plus 4 10, 10 plus 2 is 12y square, and here we have 1 plus 1 is 2, and we move the 16 in the left hand side, and you get minus 16 is equals to 0. So after a little bit simplification you can get the output in this form, and after this step we will again make some simplification here. So you get 2 times of y squared plus 12y squared minus 14 is equals to 0. And now you see that here we have the common term is 2, so that we will divide each side by 2 in this way, and you get y squared plus 6, sorry, this is y4 plus 6y squared minus 7 is equals to 0. So this is the fourth order equation, and now we can solve this equation. So here we again put x is equals to y square, and when you can put x equal to y square, I can write this equation as y square and its whole square plus 6y square minus 7 is equals to 0, and we can put here y square is equals to x, and this expression will becomes x square plus 6y minus 7 is equals to 0. And now we can just make the factors of this nice equation, and the factors of this equation in the form of x squared plus 7y minus 7 is equal to 0. And now we can take common sorry, this is the x only, this is the x term, so we can write here. So here you can take common x and you get x plus 7, and here you take common minus 1 and you get x minus 7 is equals to 0. And now we can just take common x plus 7 and you get x minus 1 is equals to 0. So here we have two cases. The first case is we can just take x plus 7 is equals to 0, this is the first case, and the second case is x minus 1 is equals to 0. So in the first case you get the value of x is minus 7, and in the second case you get the value of x is plus 1. And now we back substitute the value of x, and here you see that we have x is equals to y squared. So we will back substitute the value of this y, and you get y squared is equals to minus 7 and y squared is equals to plus 1. So now you can just take the square root on both of the sides, and you get y is equals to plus minus square root of 7 iota, because here you have, when you can take the square on both of the sides, these are gone, and here you have minus 7 square root, and you know that the square root of minus 1 is equals to iota. We can apply this fact here, or this value of iota. Similarly, here you get the value of y is equals to plus minus 1. And now here we have again two cases from here, which is y is equals to plus square root of 7 iota. This is the first case, and y is equals to minus square root of 7 iota. This is the second case, and the third one is y is equals to plus 1, and the fourth one is y is equals to minus 1. So here we have these four cases, and now we back substitute the value of y, and in the start of the question we will take the value of y is equals to n minus 7. So we will back substitute this value here. So when you can put this y is equals to n minus 7 is equals to square root of 7 iota, you will get here n is equals to 7 plus square root of 7 iota. So this is the first root of this equation. Similarly, when you can put here n minus 7 is equals to minus 7 square root iota, and you get n is equals to 7 minus 7 square root of iota. So this is the our second root, and when you can put here n minus 7 is equals to 1, and you get n is equals to 8. This is the third root, and you get here n minus 7 is equals to minus 1, and you get n is equals to plus 6. So these are the four roots of the given equation, and this is the our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.